For angles in standard position, they start always in the positive abscissa. Again, if you draw an angle in standard position, they always start in the positive abscissa. And their direction moves in a counterclockwise manner, which means it goes against the motion of the clock. And these angles, as they move from the positive abscissa turn counterclockwise direction, are positive angles. Again, if these angles are going to start from the positive abscissa and it turns counterclockwise, the value of the angle is positive. These angles are what we call standard angles or angles in standard position. If these angles moves from the positive abscissa and their direction turns rather clockwise instead of counterclockwise, the angle then is negative. If the angle moves in a counterclockwise, the angle is positive. But if the angle moves in a clockwise direction, the angle is negative. Standard angles can be converted to radian and it can be brought back again to a degree measure. So that is the main focus of our module right now, to convert radian measure to degree measure. So let me proceed with here. There is an illustration of angles which are negative and angles which are positive, depending on the direction of how you're going to draw the angle. If you draw the angle in a counterclockwise direction, the value of the angle is positive. If you draw the angle in a clockwise direction, the value of the angle is negative. Here are examples of angles drawn in standard position. We have 240 degrees. So to draw that said angle, you have to draw more than 180 degrees. So it's more than 180 degrees, probably 60 degrees more than that, which is equal to 240 degrees. The 60 degrees there is the reference angle of 240 degrees. With respect to reference angle, we will have a rediscussion on this one in our next module. But I'll just give you an overview. The reference angle of 240 degrees is 60 degrees. To draw 500 degrees, or rather, let's start with letter C. Negative 50 degrees is from the positive abscissa drawn clockwise direction. So there you have the negative 50 degrees. And for 500 degrees class, since it's more than 360 degrees, so we will have one complete revolution plus 140 degrees. Since one complete revolution is 360 degrees, subtract 500 by 360, you'll get 140 degrees more. So the red line shows the 500 degrees, while the 140 shows a coterminal angle to 500 degrees. The difference between 60 degrees in letter A and 140 degrees in letter B is that 60 degrees in letter A is a reference angle, 140 degrees in letter B is a coterminal angle. The reference angle of letter B is 40 degrees. The discussions of which between reference and coterminal will be done in the next lesson. Since we are going to talk about standard angles again in the next lesson. So we have here some examples of angles in standard position, negative and positive angles. So let's try to draw these angles then. For example, 65 degrees. So that would be positive 65. So that will be here. This is your initial side in the positive abscissa. Your terminal side is in the first quadrant. 300 degrees, your terminal side goes to the negative, goes to the fourth quadrant. So this is your positive 300 degrees. So the reference angle there is 60 degrees, which is here. For number 3, negative 120 degrees, it's more than 90 degrees. So the value or the initial side still is in the positive abscissa. Your terminal side is in the third quadrant. So this is negative 120 degrees. And lastly, negative 450 degrees. That is more than 360 degrees. So from the positive abscissa turns clockwise direction because it's negative. This is 360. If you subtract 450 by 360, you'll get 90 degrees, right? So therefore, negative 450 degrees is due south, which is this one. So this is how you're going to draw standard angles. Maybe this is not needed in our lesson for today because the point of our discussion is changing radian to degree measure. This will be done perhaps in our next module. Since in our next module, I may not specify the angles in degree measure, I may specify it in radian measure. Question as to how you draw angles in standard position? None. So to measure an angle class, we will measure it either in degree measure, as it is noted by the degree symbol, which is like a zero on top, no? And one complete revolution is 360 degrees, which means that 1 degree is 1 over 360th of the one complete revolution. And this is now the basis of how we're going to draw the radian measure. Okay? So for example, we draw 60 degrees, that's 1/6 of 360. 45 degrees is 1/8 of 360, and so on and so forth. But in the case of how we are going to draw radian measure class, how we're going to plot radian measure, probably we can plot it using the ones that I presented in your module. You can use that, the one on the right, like pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, and so on and so forth, until 24 pi over 12, which is 2 pi, or one complete revolution. You can use that, but you may apply conversion. Conversion of these angles happens as follows. So perhaps let's proceed with conversion of angles here. Radian measure class, radian measure and degree measure can be equated one over the other. The conversion of radian to degree measure is as follows. 2 pi radian is equal to one complete revolution. In the figure that I presented in your module, upper right, you have there from the positive abscissa turns counterclockwise from pi over 12 until it reaches 24 pi over 12 as it goes back to the positive abscissa, which is equal to 2 pi. And thus, the complete revolution or one full revolution, which is 360 degrees, is equal to 2 pi radian. 2 pi radian can be equated to 6.28 if you replace pi by the decimal value, which is 3.14. Or half of 2 pi is pi and half of 360 is 180 degrees. So 1 pi radian is equal to 180 degrees. Or pi over 2 radians is equal to 90 degrees. Which then proves, or which then we can use the middlemost value, which I think the one that I presented in your module as a solution. We'll use this conversion to solve problems on converting degrees to radian or radians to degrees. As in the case of how big the value is, we'll just have to use that one. So these are examples of angles drawn using radian measure: pi over 6, pi over 4, pi over 3, pi over 2, pi, 2 pi. These values can be converted by radians to degrees or degrees to radians depending on the origin of the value of the angle. So the conversion factors are as follows: pi radians over 180 degrees or 180 degrees over pi radians, depending if we convert degrees to radians or radians to degrees. So let's try examples. Number 1, letter A. Convert 120 degrees to radian measure. Notice the value 120 degrees. We made the unit degrees to words so that we will have the canceling specified. So cancel the degree measure and then now place the pi as the unit followed by the radian. You may or you may not write the radian word, but if possible, please write the radian word to signify that that value is in radian measure. Of course, all values are specified in radian measure, not unless the unit is clarified as cm or degrees or feet squared or the likes. So we have here 120 degrees, convert that to pi radian. So 120 degrees multiplied by pi over 180 degrees. So it's just like dividing 120 by 180 and then write the pi value or the pi symbol. If you wish to come up with a decimal value of 2 pi over 3 radian, then you can change pi to 3.14. Multiply it by 2 and divide it by 3. So the answer there would be 2 point something. I don't know what's the decimal value. In converting the other way around from pi radian to degree measure, so we have here negative pi over 12 radians, multiply it by, instead of multiplying it by pi radian over 180 degrees, since we're going to eliminate the unit radian, we invert the given. So we have 180 degrees in our numerator and in our denominator we have pi radians. Cancel the radians. Cancel also the pi. You're left with 180 negative divided by 12. And you divide it by 12, you get the answer, negative 15 degrees. And that is how easy our module 2 is. I purposely have it in this uh, lesson alone so that each of you guys will have a good um, pundo with regards to your scores in the midterm, pre-final. Let's try example 1, 2, 3, 4, 5 or A, B, C, D, E of number 5. Convert the following to radian measure. Again, convert the following to radian measure. Do it quickly then, and I will ask you one at a time a question, or each one of you to answer the question. Troy, 60 degrees is equal to
Uh, Radian, sir.
give me the degree measure of 60 degrees, radian measure of 60 degrees. This is
180.
180 degrees. Baliktad rin. There's a problem of your understanding. Convert degrees to radian, multiply it by pi over 180 degrees. Cancel the degrees, you'll have the unit pi radian. 1/3 radians, the answer of Miguel is also wrong. 1/3 radians,
One
wrong.
pi over 3, sir.
Very good. The answer is 1 pi over 3. So to clearly draw the solution, allow me to have it in here. 60 degrees multiplied by pi radian over 180 degrees. Cancel the degrees, you'll have there 1/3 pi radian. So the answer of Miguel lacks the pi. The answer of Troy is obviously wrong, 180 degrees. Hello? So it's just as simple as this solution class. Okay, let's proceed. Number 2. Letter B, Crystal, 30 degrees is equal to
1 pi over 6.
1 pi over 6 radian. Very good. Or you can have it as pi over 6, or you can have it as 1/6 pi. They are all but the same. Negative 54 degrees, Raisa.
Uh, 3 pi over 10 rad.
Very good. 3 pi
Negative.
over 10 rad, and then the pahabol negative. Or you can have it as negative 3 over 10 pi, or you can have it as in decimal. By the way, if you wish to have it in decimal, multiply 3 over 10 by 3.14. No? If you multiply it by 3.14, you'll get 0.942 radian. Negative 0.942 radian. Wala na pi because you now converted the pi to 3.14. But for us to say, to be safe, we'll go with this answer. Not unless the question is stating for you to give me a radian measure without pi. Hello? And 118 degrees. Let's have Trisha, 118 degrees. Negative.
Sir loading. Negative 0.5.
Negative 0.75. You are trying to give me a decimal value. You try to come up with a solution much better the next time. Let's try to solve this one. Uh, I'll solve it here. So negative 118 degrees multiplied by pi radian over 180 degrees. Always have this as solution. Cancel the degrees, you'll get negative 118 over 180 pi radian. Press that in your calculator, you'll get negative 59 over 90 pi radian. Or the answer of Tricia was negative 0.66 pi radian. Na decimal. Pero nagya po pi. If you wish to cancel the pi, you multiply it by 3.14 and then you'll get the final decimal value of 2.06 radian. Without the pi, because you now replace the pi with 3.14. So this is the solution or the algorithm to find the value of the radian measure given the degree measure. If we do the other way around, finding the degree measure from a radian measure, say for example here, we have pi over 6, convert that to degree measure. So we have pi over 6 times pi radian, or let's put the value or the word radian so that we will convert and eliminate the pi radian easily. So multiply the given radian measure by 180 degrees over pi radian. So cancel the pi radian, leaving 180 degrees divided by 6, and the answer there is 30 degrees. Pi over 2 is 90 degrees. How about 11 pi over 18? Lex. Negative 11 pi over 18.
One hundred ten, sir.
Very good.
110
110
degrees.
degrees. Negative
Negative
110. Ayan. So how did we do that again? If you wish not to include the pi word, you can have it like this. 11 pi over 18 multiplied by pi and 180 degrees. 180 over pi. So just cancel the pi, class. It's just as if multiplying the fraction by 180 degrees to get the degree measure. In simple terms, replace this by 180 degrees because 1 pi radian is equal to 180 degrees, right? Therefore, it's safe to say that you may replace the pi by 180 degrees. In other words, in letter D, this is equal to 180 degrees divided by 9, which is equal to 20 degrees. Make sense? So it's just like replacing the pi by 180 degrees in changing radian to degree measure. Question? Clarifications? Okay, let's try number 1, 2, 3, and 4. In your seats right now, you try number 1, 2, 3, and 4, and then chat your answers if you're done. I'll be expecting answers after 4, 5 minutes. You can do everything in your calculator, right? You can just press directly your calculators if you wish to. How about number 2, right? Number 3, number 4.
Di siya ma-enter ka ng return bitaw.
What do you mean enter return?
Ako siya i-stack ba?
Okay. Sige, one at a time. Go, go. So, number 1, 1/6 pi radian is correct. 1 pi radian, 1 pi over 6 for Steve, correct? 1/6
Sir,
pi rad for Raisa, correct? Yes, Miguel?
during the ST, sir, I do not have a pi symbol here in my laptop. Can I just write the word pi, or should I
Okay.
copy paste it
But
somewhere?
let me correct the spelling of Raisa for the word pi. Pi is not spelled P-I-A, so as with Miguel. Pi, this symbol, this symbol is called pi with the spelling P-I.
See, thank you.
Okay, good. So you can just use that word in your answers in Edmodo. Again, the use of the symbol can be followed, but if you use the word pi with the spelling of P-I. Number 2 is 3 pi over 10. I think this is the one that is above. This is repeated naman pala. So this is 3 pi over 10, then 20 degrees and negative 110 degrees. Yes, this is all true, correct. I think there's no need to continue because these given are the ones we have on the previous. So to summarize, we have here some tables with respect to the conversion. 0 degrees or 360 degrees is 2 pi radian. Pi is 180 degrees. Pi over 2 is 90 degrees and so on. So you use the picture that you have here. Or you can just simply convert. If you don't know the conversion of 7 pi over 4 as 315 degrees, you solve the conversion. With respect to coterminal, it's just not, you just don't need to have that in class. Please focus on your module. Let's try to answer some items in your module and the rest will be up to you.
Knowing the topics there, the topics and intent have been cleared out. Specific details to support the topics and insights have already been known.
Let's have
Together, structuring the composition would now be back.
an item here being answered.
Know the
Let's
process
try.
he or she wants to use.
What will we try? Any suggestion in activity 1?
That the writer wishes to employ in the creation of the sheet.
Let's try number 1, 3 pi.
A lot of methods.
So to solve number 1 class, I'm solving number 1. 3 pi.
Contrast, chronology, description, you have definition, exemplification, cause effect.
Okay, 3 pi radian will be multiplied by the conversion of radian to degree measure, and that is 180 degrees over 1 pi radian.
Some writers might forget this.
Over 1 pi radian. So if you multiply 3 pi radian by 180 degrees over 1 pi radian, you cancel the pi and the rad, leaving 3 times 180 degrees. Multiply 3 and 180 degrees, you'll get the answer 540 degrees. So that's how you solve problems in activity 1. But there's a but. You notice number 5. This is number 1. If you look at number 5 class, pi or 12 over 7 radian. What is the difference between the given in number 1 and the given in number 5? So as with the other given. Wala siya pi unit. Still the same. To convert the degree measure to radian measure or radian measure to degree measure, you're still going to multiply it by 180 degrees over 1 pi radian. But this time around, your pi will be converted. So before we're going to proceed with the solution, allow me to simplify first the conversion of pi radian as 180 degrees over 3.14 radian. Because you cannot cancel any value in the solution, unlike the previous solution where we can cancel pi and radian, right? Leaving 3 times 180 degrees. But here, we don't have the value of pi that we canceled. Instead, we will just cancel the unit radian and pi will be changed to 3.14. So our solution then will become 12 times 180 degrees divided by 7 times 3.14, such that the final answer will just have to have the degree symbol without the pi as our denominator. So we have 12 times 180 over 7 times 3.14. So you'll get the answer 98.27 degrees, or you can express your answer in DMS as 98 degrees, 16 minutes, and 16.16 seconds. So you can have it done in that way. So there you have the solution for number 1 and the solution for number 5. Questions and clarifications?
did we have you heard that part when I enumerated a few like seven a bead writing pattern?
Wala tayong tanong. Okay, let's try
Did you turn your cameras on?
activity 2 then.
By the way, can you see me?
Oh my God, naglalag ako.
Oh, problems.
So in activity 2 is then an easy access to the answers. Let's try number 1.
Problems.
So example in number 1 class, 65 degrees. You multiply that to the conversion of pi radian over 180 degrees. So what will you cancel is the unit of the degrees, leaving the answer 65 pi over 180. You just have to simplify it, like 65 divided by 180. You'll get 13 pi over 36 radian. So there you have your answer in number 1. Solutions are the same on each of the items in activity 2. There's no differentiation with respect to the given in number 1 because all the given in number 2 are in degree measure. The thing that you need to look at in activity 2 are the symbols negative and positive. Okay, questions? With respect to activity 3 class, there's an example in your module which says that for you to find cosine of pi over 2, convert first pi over 2 to degree measure. So still there's the idea of conversion. So we have now 90 degrees as the value that you need to get the cosine of. And then the rest will be done with your calculator. Cosine 90 degrees, press that in the calculator, the answer is 0. Question? I think that is all for our lesson today. If there are no questions, we end the call at an earlier time.